Delayed progression occurs between mid-stance and terminal stance and is characterized by a hesitation or delay in the forward progression of the prosthesis as it advances over the midfoot. It is not necessarily related to knee instability and may even be seen or measured kinematically in individuals with an otherwise vigorous dynamic gait. Delayed progression at mid-stance can be measured in the braking and propulsive shear pattern of the prosthetic side, as the graph illustrates. The transition between braking shear and propulsive shear is uneven and can be seen by the flattened area during mid-stance. This deviation may be difficult to observe visually, and identification is often dependent upon verbal feedback from the patient. The individual may experience delayed progression as a sense of hill climbing or climbing out of a hole. It may result from a forefoot lever that is too long or too rigid. It is also seen when insufficient dorsiflexion or neutral alignment has been placed in the ankle of the prosthetic foot. Delayed progression can also be caused by a patient wearing a shoe with a lower heel than that for which the prosthesis was originally designed, such as sandals or negative heel shoes. In the gait of a non-amputee, the pretibials not only control rapid descent of the forefoot, they also advance the tibia relative to the forefoot, even as the foot moves into a plantar grade position. In this more forward placement, the tibia is better positioned to advance into mid-stance. This function is only partially replicated in prosthetic design. It has been shown that the bladed-style prosthetic feet provide increased dorsiflexion compared to other designs. While the dorsiflexion is increased, there is a gradually increasing resistance to dorsiflexion at the terminal end of the range of motion due to the spring-back nature of this general foot design. Foot and ankle designs, which are more rigid, elevate the center of mass in terminal stance and pre-swing more than bladed-style prosthetic feet. The flexible blade pylon allows the center of gravity to sink slightly. This lowered center of mass results in a decrease in the vertical force in the sound limb seen in the bladed-style prosthetic feet when compared to various other foot designs. The decrease in the vertical force is attributed to the reduced elevation of the center of gravity in late stance provided by the increased dorsiflexion.